Good morning, everyone. We'll give everyone another minute or so to get in here. We've got 17 students in here, and I think we have 24 on the roster. So just hang tight for a minute. Okay, I think there's 22 in here now, so I guess we'll get started. So welcome everyone to Precalculus for the spring 2021 semester. My name is Robert D. Giovanni. Everyone can hear me? We're good? Thumbs up. All right. I'll be the instructor for the course. And just to give you a little bit of background, I've been teaching at Northwest Vista for too long, I guess. Somewhere around 2000 is when I started. So I'm like moving up on 20 plus years there. So I'm only telling you that because sometimes you get an instructor who's like a part-time instructor and they're just teaching 1 or 2 classes. I teach full loads, and normally I teach the calculus sequence. So normally I teach Cal 1, Cal 2, Cal 3. This is the first time I've taught pre-cal in probably 4 years. So this is going to be kind of an exciting adventure for me to get back into this class. Anyway, with all that said, I did send out a video through Canvas email a few days ago, but that was just a quick introduction to the class. If you didn't look at that, please take some time to watch that. It's just to get some of the basic administrative stuff out of the way so we don't have to spend time here today. Basically, the way the course is going to lay out is you're going to be required to be here on Zoom. Going to go through lectures I'm going to be using and my little whiteboard here. Where is it? So I'll be using a whiteboard. I'll be writing on this and stuff, and then I'll record all these lectures and put them on YouTube. And then you'll be taking exams. You'll be doing homework online using a system called MyLabs. And I'm going to be providing homework solution videos for all those homework assignments. So I usually have those videos already made before class, before the semester starts, but because I haven't taught this in 4 years, I don't have the videos. So what I'm going to be doing is after our class ends, I'm going to be going to my office hours and I'm going to be doing your homework. So if you want to actually go and join that session, you can, because I'm just going to work through all the homework problems. So just so you know, that's the plan is for me to post the homework solution videos within like a day of us having class. Hopefully that makes sense. Okay. On our Canvas main page, here we go. You have the link to MyLabs. You'll need this code. You go ahead and get registered. I think I saw this morning that 8 of you have already registered, which is good. But everyone needs to get registered there. It shouldn't cost you any money. It should be free. And that's where you'll go online and you'll see your homework assignments. So I think I can get to that. Let me see here. It should look something like this for you. It should look like this. And it will have your homework assignment when it's due. And so these will start to load up as the semester goes. You'll see each assignment show up. So you just click on it and then it's each question. You bring up the question and you go through these, right? And it'll give you a score. And I think you get 5 tries at each problem before it counts it wrong. So All of your homework for the entire semester will count for 15% of your grade. And then the rest of your grade is exams. We have 3 exams, exam 1, exam 2, which are each 25%, and then the final, which is worth 35%. This is all in the syllabus. You can go read this on your own, but I just want to give you kind of a brief overview of the way things are going to work. So later on today, during office hours, I'm going to open up this assignment and I'm going to do these problems. Now, I may skip 1 or 2 because I'm like, oh, that one's just like the other one. As long as I'm covering the main topics, I'll work through the homework assignment. All right. So expect for me to do about 80 to 90% of the problems. All right. Any questions at this point? Okay. So students always ask me, you know, let's say it's like the week of the final exam and your grade is not where you want it to be. And students are like, well, you know, is there anything I can do for bonus, or you know, what can I do to bring my grade up? And I'll tell you at the end of the semester that there's nothing that you can do to bring your grade up at the end of the semester. The way to bring your grade up, I'm going to offer certain bonuses. And the first type of bonus that I'm going to offer is you being on Zoom with your video on. So if you don't have to do this every single day, but if you are consistently joining the Zoom session with video, I will consider that as bonus. It's not to penalize people who don't want to do the video, but it's much easier for me to engage with you if I can see you rather than just see a name. And the way this is going to work is as we go through the lectures and I'm going through problems, I have a list of all of you right here. And each day, and what I'm going to do is I'm going to mark in these boxes, I'm going to call on people randomly. So every day you may be called on to help get through a problem. And so if I call on you and you're not here, of course, you'll be counted absent. But if you don't respond, or, you know, if you're there, right, I see your name, but you're not responding at all, then I will count you as being, you know, not participating. All right. So there's like a participation part of this class that will add bonus to your grade. Okay. Any questions on that? I may also offer bonuses during class, like instead of a quiz, we'll call it a bonus, where I give everyone a problem or something like that. And then maybe I'll ask you to like hold it up to your camera or something. And then I'll give you some sort of bonus / quiz grade. So this is all to help your grade, but the main point is that any sort of bonus for the class is going to be occurring throughout the course, not at the end where, you know, I offer some additional assignment. The other thing about exams is, you know, inevitably somebody's going to ask, you know, do you get a test retake, right? So if I don't do well, can I do a retake on the exam? And the answer is no. All right. So there's no test retakes. You have to, the day of the test, you have to show me what you know on that day. So I don't want there to be this thing in the back of your mind where like, well, if I don't do well, he's going to let me retake the test. That's not the case. All right. And it's not to try and punish you, but it's, you know, test retaking is a high school thing. Like, I'm not sure why high schools love to do that, but, well, I know why they do it, but in college, you don't get chances to retake exams, especially at universities. So you have to get used to the idea of a high stakes, high stress exam, right? So you want to start to mentally prepare for that. Now, what I will do is I will replace your lowest exam with your final exam grade if your final exam grade is over an 80. So for example, let's say you get a 50 on your first exam, and then you take your final and you get a 70. Well, you're going to keep your 50 and you're going to keep your 70. But if you get a 50 on the first exam and you get an 82 on the final, I'll replace your 50 with an 82. So you have to do not just pass the final, you have to do like B-level work for me to consider dropping. Does that make sense to everyone? Okay, so any questions at all? We're all okay? All right, so you know, everybody here is going to be coming into this class at a different level. Like everyone had to take college algebra to get here, right? But we all know some people like barely got through college algebra. Some people, college algebra was easy. You know, some of you are coming out of high school. Some of you are in high school, and you're doing this like a dual credit. So everyone's kind of at a different place, and we're going to kind of see as the semester goes on where you are, and hopefully we'll be able to identify any gaps that you have in your algebra. We can identify those, and then you can get tutoring. So I recommend that if you're struggling with any concepts, join my office hours, which are on the syllabus. Again, they're right here. Okay, these are the times that I'm available. If you can't come to my Zoom office hours, then just go to the Northwest Vista main website and just type in like math tutoring or something like that. And it should bring up a link. Whoa, what happened? Okay, so you can click on one of these tutoring services, and they have Zoom sessions that you can join. All right, and they have pretty good hours, like, you know, open till like 9 o'clock, Monday through Thursday, 9 p.m. And there, if you click there, you'll get like a live one-on-one tutor. All right, and you can say, hey, I'm struggling with factoring, you know, whatever it is, and they can help you out. Okay, so I just want you to know that there are resources there available to you. Any questions?
Yes, sir. For our exams, will they be on the same website as the homework?
Okay, good question. No, now the exams, if this is in the syllabus, so I'll let you read this later in detail, but I'll give you just a basic idea of the way the exams work. We'll all show up at this Zoom session for the exam. And then what I'll do is I'm going to email everybody the exam. All right. So I'll send it, you'll open it up there at home, you'll open it on your computer. And then I'm going to take 10 minutes, maybe 15 minutes for everyone to write down all the problems. Okay. So you're going to write down all the problems on a piece of paper. And then after that 10 or 15 minutes is up, you have to turn off your computer that's in front of you. You have to use either your phone or a laptop, and you've got to set up your camera somewhere where I can see you. Let me show you exactly what I mean. This is where people start getting really bummed out because they realize that this is the way I do tests. But where's the picture I had? Oh, here we go. This will work. So this gives you like a basic idea of what your camera setup kind of has to look like during the exam. So you've written down all the problems, right? And now you're going to be sitting at whatever workspace you have. I must be able to see you, what's in front of you, like what's on your table and what's in front of you. Notice how you can see me here. You can see my desk. You can see that I don't have like a bunch of formulas, you know, like taped up to the wall or anything, right? And so I can maintain the integrity of what we're doing here. Okay, so I know that it's you taking the test. I know that you're not using any additional resources. In fact, when the test starts, you'll have to take the pages that are in front of you, and you're going to have to hold them up to the camera and turn them around and show me every page in front of you, so that I can verify that that we have a level playing field. Okay. The last thing I want is for James to be diligently working hard at this class, and then for some other student to be sitting there cheating the whole way through the test, right? So I want this to be fair. If you can't set up your camera properly for the test, then I won't let you take the test. All right, so you have to, and don't freak out right now. We're going to get some practice before the test. We're going to do a practice setup so that everyone knows how to, you know, how they're going to set their camera up, whether or not that view is acceptable to me. And so don't panic yet. All right. Then when you're done with the exam, so let's say, you know, you're going to be doing paper and pencil exam, right? So when you're done with it, now what you have to do is get that to me. So what you'll do is when you're done with the exam, you'll come on to the chat here in Zoom. You'll get in the little chat box and say, hey, I'm done with the exam. And then what you'll do is you'll shut down Zoom, and you have 10 minutes to get that test to me through a Dropbox link that I'll send to you. So within 10 minutes of finishing the exam, I have to have your exam in the Dropbox. So you're going to probably be taking pictures of all of your pages and then sending those to me electronically. Does that all make sense? We're going to practice. Don't worry. Everyone's going to have a different scenario. Some of you have scanners. So if you have a scanner at home, you can just scan your test. Some of you are going to have to use your phones and then use some app or something like Cam Scanner or something. We'll go through some dry runs of this, trust me. But by the day of the test, everyone should know how to set up their camera and how to send me a file in the appropriate format.
Can we print out the test?
Yes, you can print the test if you have a printer. Yep. I just can't assume that everyone does. So that's why I'll give everyone 10 minutes to write the problems down. Any other questions about that? Y'all okay with all that? It's a pain in the ass, I know, but you know, it is what it is. It's the best that we can do at this point, you know, with the way things are. So, and I meant to tell you in the beginning, I really do appreciate all of you even enrolling in the class. I mean, it's tough to have to do it this way, but you know, if you're engaged and you know participating, you'll learn what you need to learn, and we move on, right, to better days, hopefully. So, you know, what is Precal about, right? Obviously, the name Precalculus means that this is somehow like a prelude to calculus, right? So it makes you think, well, there's a lot of things here in this course that I need to know in order to do calculus. That's what it seems like the name indicates. But in fact, it's not really that case. I mean, there are very important things that we have to learn in this class that you will need in calculus. But this class is really about you maturing as a mathematical student. Like this is, now we are going to turn the level of difficulty up on things so that you'll be more prepared for the calculus level of things. So we're just kind of cranking everything up a little bit, and you're hopefully going to become a better student in this class. Now there's main ideas that you have to know, and I always tell my pre-cal students, there's two main things that we have to take away from this class. You have to know the basic trig functions. You need to know their values at the common angles, which right now may sound completely foreign to you. And then you need to know how to solve trigonometric equations. Those are like the two main things. If you can't do those two things, you'll be dead in the water in Calculus 1, all right? You have to be able to do those. So, you know, one of the advantages to having an instructor who teaches the entire calculus sequence like I do is that I know what you need, right? It would be different if this was like the highest class that I taught and I had no real like idea of what you need later. So that's a good thing for you, because there are certain things that we'll talk about and I'll be like, you know what, you know, if you kind of get it, you'll be fine. And there are other things that I'm going to tell you, hey, you have to understand this, all right? I want to take a quick poll. Let's see if this works. It didn't work yesterday. It's still not, why is it not working? This is stupid. Okay, yes, no. It's supposed to save these, but it didn't. Yes or no. Okay, so I'm just gonna ask the class a quick question. I want to take a poll. If you can't take the poll, don't worry about it if like your phone doesn't let you or something. So this is just a quick yes or no. The question is, if you know or not, do you know if you have to take Cal 1? So, you know, some students need pre-cal, but they don't need Cal 1. So I want to know how many of you know that you need Cal 1. And if you're not sure, just put no. And I'll just give you another like 10 seconds. Wow, we have 24 people here. That's everybody, I think. It's good. Interesting. Okay, so check this out. Let's see, can y'all see that?
Yes, sir, I can see it.
Okay, so 64% of you for sure need Cal 1. and 36% either don't know or know that they don't need Cal 1, which is kind of interesting because, you know, it's weird. If you look back over the history of college education, what happens is that, let's say you have a lot of people, I'm willing to bet that a majority of the people who have said no here are like pre-med or something like that, or something medical. What happens is that as more students want to become doctors or whatever it is, and you have all these students want to do this one thing, what the Texas Coordinating Board does is they just turn up the math requirement. So in other words, if you wanted to be a doctor like 10 years ago, you could probably have just taken statistics and you would be fine. You just go through med school. Now most medical students have to take Cal 1, and a lot of them are having to take Cal 2. And it's not because you need the calculus, it's because they're trying to weed people out. So they're like, anytime you need to weed people out, they just up the math requirement, right? That's the way they do it. So what we have here is, you know, roughly 1/3 of you, this is it. This is the last math class you need. And 2/3 of you need Cal 1. So it's, you know, I have to keep that in mind as I teach, but please understand, I always teach my classes as if you need the next class. Okay, so I have to teach this as if you need Cal 1. All right. So for those 8 people, 36% that don't need another class, y'all are just going to have to hold on and enjoy the ride because the other students need to know all this, right? Okay. I think I'm ready to get started, unless anyone has any questions. We're going to work out any glitches. We're going to, you know, if you're having any issues with getting online and doing your homework, you know, we'll get all that squared away. All right. So don't panic too much about that. You're here on the first day, and that's a good thing. So, all right, I am going to now, oh, the schedule. I wanted to show you the schedule is on our main Canvas page, but this just kind of shows you what we're covering each day. And this may change depending on how things go. So today, right, we're supposed to start 12.5 partial fraction decomposition. Now, this might be kind of mind-blowing to you because we're going to start this class in the last chapter of the book. And then we're going to go back and talk about chapter 2, section 4, circles. Then we're going to jump to 7. Then we're going to stay in 7 for most of the time. Quick jump back to 6. Then we're going to do 8. So really, like the main components of this class are chapter 7, chapters 8, and chapter 9 also, this first part. So 7 and 8 are the big components of the class. We're starting in 12 though, and it's going to be kind of strange that we're starting here, but there's a lot of algebra in 12. So we're kind of picking up, you just came out of algebra, and so we're going to kind of continue with a little bit of algebra. And then we're going to get into circles and trigonometry and stuff like that. So, we ready? We're going to start 12.5. Okay. You know what? Is this recording? Okay, it is recording. My class yesterday, it wasn't recording, but it's good. And remember, I do plan on calling on you, okay, randomly. Today, I'm going to just call in alphabetical order, but from here on out, I'll have my computer like randomly shuffle all of your names every day, and then I'll just start at the top of that list and go down. So, but I will also know if I called on you the day before, so I will make sure I get through everybody before you're called again. All right. All right. So I feel like there was one more thing I wanted to say. Oh, yeah, partial fraction decomposition. So for those of you who have to go on and do calculus, right? This topic will not show up again until about 2/3 of the way through Cal 2, all right? But once you, so for those of you who need Cal 2, you won't see this again for at least another like semester and a half or 2. So maybe a year from now, this is gonna come up again. So this is the type of thing where you're going to want to keep these notes don't throw them away if you're going to take Cal 2, because once you get to that partial fractions in Cal 2, they're not going to go through this again for you. They're going to assume you know how to do this, and then it's part of a larger problem, if that makes sense. Yes? Would y'all like to see it? I can show it to you. I don't know. I'm probably wasting time here, but I can go to my Monday, Wednesday class from last semester. Let me see. No. If I can't find this within the next. Oh, I think that was it. Hold on. There it is. Okay, so here it is. Right here. This right here. This was just this past semester. So this was in late October around Halloween. We were doing this problem here, and we were doing partial fraction decomposition right here. So Cal 2, way into Cal 2 is when you'd see this again. So there's only a few things in pre-cal that are like this, where you're going to need them later, like way later. So I'm just pointing out this is the one that you need way later. Most of everything else that we do, you'll need in Cal 1, but this one you need in Cal 2. Okay, so partial fraction decomposition. So let me try and motivate the idea here. All right. So first thing, let's talk about adding fractions. Okay, so if we add fractions, and feel free to stop me, just like, unmute yourself and say, hey, blah, blah, blah. If you have a question, just interrupt me. That's okay. All right. Because you can't really raise your hand. It's hard for me to see that. But so if we want to add fractions, let's take the easiest case first. Let's say we have 1/4 plus 2/4. I'll go with 2/4. Okay. If you want to add two fractions together, you have to make sure they have the same denominator, right? If they have the same denominator, you can just add straight across. So this becomes 3/4. Okay, now what if they don't have the same denominator? So what if it's like 1/4 plus 2/3? Well, then you need a common denominator, right? So you have to multiply each of those fractions by 1, but you have to be clever about it. I'm going quickly through this because this should be review stuff. Like here, I multiply top and bottom by 3. Top and bottom here by 4. That way I get a common denominator of 12. And so this would become what? 3/12 plus 8/12. And then you can add those two together. What's that? 11/12. All right. This is all familiar, yes? Okay.
Yes, sir.
So when we add fractions, we have to get common denominator, and then we can just add straight across. Now, let's look at adding fractions where we're not dealing with numbers, but expressions. So this would be adding, well, let's just do an example here. How about if we did, let me move over here. What if we did 3 over x plus 1 plus 4 over x minus 2? Okay, so if we needed to add these two together, then we would have to get a common denominator. Right now, the denominators are not the same, right? We've got that one, we've got that one. These aren't the same denominators. So the common denominator would be, can anyone tell me what the common denominator would need to be here?
X plus 1 times x plus 2.
Yeah, it would have to be the product x plus 1 times x minus 2. So this would be our common denominator that we'd need, right? So that means on the first fraction, I need to multiply the top and bottom by x minus 2. And then on the other fraction, I have to multiply top and bottom by x plus 1, like that. So very similar to what we did here, except instead of using numbers, we're using expressions to make the denominators match. Okay, so if I multiply through here, on the top, I have to distribute the 3 through. So we get 3x minus 6 over my common denominator. And then plus, now I distribute the 4 through here, so I get 4x plus 4 over x minus 2 times x plus 1. So we're saying that that line here is equal to this line. And now I can combine them because they have the same denominators. So I will have, I join the numerators together. And here's my denominator. So one more step. I'm going to go ahead and clean up the numerator, combine like terms. And what we have here, 7x, and then minus 2. And on the bottom, I'm going to go ahead and FOIL this, like multiply through here, do this thing. It's actually called expanding, but most of you know that by FOIL. So what's that? X squared. I'm going to go ahead and collect the like terms in the middle. What do we get? Minus x minus 2. And that would be our result. Okay, any questions on that?
Would it be acceptable to leave it in the form before expanding it?
You mean like this, 7x minus 2 over, and then not multiply that out?
Yeah. Would that be acceptable, or do we need to expand?
I mean, it is the same thing, right? It is exactly the same expression, so it would be acceptable. But I have a little twist here to the plot. Okay, so let me just write down exactly what it is we started with. Okay, we started with this. We were adding this, and what we're saying is that equals this. Okay, we all agree? This is what we just did. So going from here, the left side, to the right side is something all of you did in college algebra, right? Today we are talking about this thing called partial fraction decomposition. And this word decomposition should make you think like taking apart, right? Like when you decompose, that something is breaking down or coming apart. What we're interested in is not this operation of going from left to right. We want to know if it's possible to start here and end here. Pull that apart somehow to get back to this. Okay, so the top one is just, adding. That's all we're doing there. We're just adding to go left to right. But going from the right back to the left, this is partial fraction decomposition. I'm just going to abbreviate it. Partial fraction decomposition is taking an expression and ripping it apart into the sum of a bunch of things. And this operation of going from right to left is not easy. You might think it is, but it's not, because think about this. Just go back up to this step right here. Let's go to where we were here, right? Let's see where that came from. That came from this, right? So where did this 7 come from? This 7 came from a 3x and a 4x being added, right? But let's act like we don't know that. How many different ways could you get 7x? Right? You could do 2x plus 5x. You could go 1x plus 6x. You go 9x minus 2x. Do y'all understand? Like, how we get a 7x here is not clear if we're going backwards. If we're going from left to right, obviously you just add them together. Does that make sense? That it's not obvious how you would go backwards here? And so what we need is a procedure. We need a process, like a set of steps to get us from the right to the left. And so that's partial fraction decomposition is all about a process. And so I'm going to start to introduce you to this process now. All right. So we still don't know right now how to do this. That's what today is about. All right. So we're ready to do it. I need to get some things out of the way first. We have to get some terminology out of the way. That way, when I start talking, you're like, what the hell is he talking about? That we're all clear. So first thing, some terminology. I'm just going to put terms here just so don't have to write so much. Okay, do we all know what a polynomial is? All right, let's call on our first person. Okay, I'm gonna mess names up, but is it Isa? E-Z-A, Isa?
Yeah, kind of. Isa?
Isa, okay, I can do that, Isa. I'll still mess it up later, but let me put here something to help me with that. Okay. So Isa, polynomial, any idea?
No, not really.
Like an example of what a polynomial, like, It's okay. If you're just not sure, you're not sure.
Yeah, I'm really not sure. So
Okay, that's fine. So if I call on you and you can't answer or you're unsure, you're not going to get docked points, okay? You're not penalized. You get credit for being here and at least responding. And I don't want anyone to ever feel humiliated or embarrassed. Look, I mean, you're here to learn, right? So Issa's about to remember, because I know you're just not connecting it. I know you've seen a polynomial. So can anyone give me an example? Just an example of a polynomial.
Isn't it like it has something to do with like two numbers having the same power?
Okay, so it has something to do with powers.
Isn't it like two equations that have the same power?
Yeah, it's
You're in the right
two,
like-
ballpark.
like
I know
several
an example.
different
X squared
numbers
plus,
Okay, I think I hear
with
Lauren.
different variables.
is it like x squared plus x plus 1?
Okay, that is an example of a polynomial. So poly is the word, poly means many, right? Many nomials. A nomial is basically a number with x, okay? So like 4x, that's called a monomial. You could write 3x squared, that's a monomial. You could write negative 5x to the fourth. Those are all monomials, mono meaning one, monomials. Okay, a polynomial is just a bunch of these added up together, added or subtracted. So this is an example of a polynomial right here. So in college algebra, you dealt with polynomials. I know you graphed polynomial functions, you know, the ones that look like little roller coasters and stuff. So a polynomial is any sum or difference adding or subtracting of monomials. Monomials are either numbers by themselves or numbers in front of powers of x. Can somebody give me just another example? Because this one has 3 terms. Does it have to have 3 terms?
No, it could be like 3x plus 2.
3x plus 2. Okay, that would be a polynomial also. You could even have just the number 5. Just number 5 by itself is a polynomial. Now, even though there's not an x there, you have to kind of imagine that there is an x. There's an x to the 0 power. X to the 0 means anything to the 0 is 1. So this is really like a 1 times 5, which is just 5. So all of these are polynomials. Everyone clear on that? And we could keep going and listing more and more and more. Okay, now, what about the degree of a polynomial? What is the degree of a polynomial? And let me ask Leslie. Is Leslie around?
So the degree is the power, so like 3x to the second. The degree
Okay, so
is
any power, or like let me write one here. Let me write one down, Leslie. What if I wrote x to the 4th minus 4x to the 7th plus 1? That is a polynomial, right?
yes.
Okay, but what is its degree?
Would it be to the 4th and then to the 7th?
Okay, so you're on the right track. It has something to do with the power. The degree is the highest power that you see. Okay,
Oh,
so the degree would be the 7, right? So for a polynomial, the degree of it is the highest power we see. Highest power of x. Is that clear to everyone? So on the examples we had before, the degrees, I'm going to highlight them. These are the degrees in yellow of these 3 polynomials. The degree of this one is 2, the degree of this one is 2, the degree of this one is actually 0. Right? So if you just see a number by itself, the degree is 0. All right, we good? Okay, so now next thing, shifting gears. Okay, we're going to shift gears away from polynomials. What are rational functions? So I'm not going to call on anyone here, but I'm just going to write down what a rational function is. A rational function, by definition, a rational function, rational comes from the word ratio, ratio meaning fraction, okay? A rational function is simply a polynomial divided by some different polynomial. So if you ever take two polynomials and make a fraction out of them, you now have what's called a rational function. And you did study these in college algebra also. All right, this is where you had vertical asymptotes, horizontal asymptotes, and maybe if your class you talked about slant asymptotes. Does that kind of ring a bell a little bit? Okay,
Yes.
so rational functions is a polynomial divided by a polynomial. All right, now in this class, I'm going
If
to.
you said a different polynomial, it has to be a different polynomial.
Well, if it's the same, if they are the same polynomials, they would basically reduce out and become one, right?
Mhm.
Which would be kind of an uninteresting function because it would just be the number one. So it'd be like constant the whole time. So if they differ, then you're going to have something interesting happening. Let me show you a quick example.
But it doesn't disqualify it from being a rational function.
It does not disqualify it. No, that is a very good point. Now we won't see anything like that, but it still qualifies. So let me give an example here. Let's say we took x plus 1 and divided it by, let me do something different, x squared plus 1. Okay, so if you look at this here, this is a polynomial on top, x plus 1 divided by x squared plus 1. Those are both polynomials. And here's the graph of it, okay? Now, if I change the top to x squared plus 1, then now it's just constant. It's just the constant 1 function because these would just reduce out and become 1. That makes sense, everyone? But it still could be considered a rational function. Okay, so from here on out, when we talk about rational functions, I'm going to say the numerator polynomial is, I'm going to call it P, and the denominator polynomial, I'm going to call Q. All right, so P is the numerator's polynomial and Q is the bottom one. Okay, we have one more thing we have to do before we can talk about partial fraction decomposition. We need to talk about factors. Okay, so when you're in college algebra, you're taught how to factor, and factors should have been a major topic in college algebra. But my experience is that students are at very different levels when it comes to factoring, because factoring truly does take like months and months to get good at. And in college algebra, you only have a few weeks to get it. So if we look at what factors are, let's say we started, let's start with this, x squared minus x minus 2. That actually, I'm taking that from our previous example. Where was it? Remember when we did this earlier? We had this and we multiplied those two together and we got x squared minus x minus 2. If we were asked to factor this, that would mean to take it back to this, just the bottom, not the whole thing, just the bottom. So in college algebra, you should have learned how to factor this. And everyone's going to have a different method for this, but I'm just going to write down what it is. So if we look at this as an example here, if you start with this polynomial and factor it, here's the factored form. Now, what you need to understand right now, what's important is that this factor and this factor are both what we call linear factors. And they're linear because each of the x's we see here are raised to the first power. That's what makes each factor linear. Remember, lines, if you were to graph a line, the general equation of a line is y equals mx plus b. And if you look at just the mx plus b, this is just a number in front of x plus a number. And that's what each of these are. It's just a number in front of x plus a number, or a number in front of x minus a number. So they're linear factors. Now let's compare that to something like this. What if I told you that I had taken some expression and factored it, and let's say it looked like this. Okay, so look at this. This right here is a linear factor, but this one is not. And the reason it's not is because we have x squared. And so we call this a quadratic factor. And additionally, it's called irreducible. Oops, hold on. I want to, yeah, sorry, I was bringing up some of my other notes. Irreducible. All right, so what do y'all think the word irreducible means?
It can't be reduced.
Okay, which means what? What do you mean? What do you mean reduced?
It's
can't
not
be further
factored
small.
anymore.
Can't be factored anymore. Okay, so if we look at x squared plus 1 by itself, there is no way to break this down into like two other pieces. You can't. Now, what if it had been x squared minus 1? Could we have broken that down into two pieces?
It'd be x plus 1
Yeah.
times x minus 1.
X plus 1 times x minus 1. So this is a difference of squares, and we have a formula to break it down. This is a sum of squares, and there is no way to break a sum of squares down. So anytime you have a quadratic factor that you can't factor anymore, it's called irreducible. Would y'all like to see another irreducible one? I'm going to show you one more. Okay, I have to make this one up. Hold on. What if we have x squared minus x minus 7, and then x plus 1, and then how about x minus 3, and then how about that to the second power? Okay, so look at that right there. Look at that expression. I want us to look at each of these factors. So the easiest one here is this one. This one is linear. Everyone agree? That's a linear factor? Okay.
Yeah.
What about this one? It's linear, right? X minus 3 is linear. But the squared means that we actually have two of those next to each other. So that actually means we have x minus 3 times x minus 3. That's really what that means. So what we call this is a repeated linear factor. Okay, so this one by itself is a linear factor. This is a repeated linear factor because of the squared. Had that been instead of squared cubed, it would still be called repeated. If it was to the fourth, it'd still be called repeated. You're going to see why this is all important in a minute, all right? But we have to get the terminology down first. This one is a quadratic. It's quadratic because we have an x squared here on the x within the parentheses, and it's irreducible. I'm just going to put IRR. It's irreducible. Why is that irreducible? That means I can't factor it. How do I know I can't factor it?
Because you had two negatives.
Do you have two negatives? Does that guarantee it?
Is it because the
But
7?
you know what? Hold on. I actually needed to have put a plus here. That's my fault. Sorry. I have no idea why I forgot to put plus here. I mean, I meant to put plus here. I put minus.
Isn't it because you have that x thrown in there, and that x then makes it irreducible?
Well, just the x by itself isn't what makes it irreducible. What makes it irreducible is if you tried to factor this, you would run into a problem. You'd run into a major problem. And one easy way to do it is, do y'all remember the quadratic formula? Negative b plus or minus the square root b squared minus 4ac all over 2a. Do you remember that's how we solve quadratic equations, right? To use this formula? Well, if you were to look at that factor and set it equal to 0 and try and do this, what you would get is underneath the root here, if you figure out what all that is, you would get a negative number. And then you're trying to take the square root of a negative number, which means you can't do it. And so that means this is not factorable because it doesn't have any solutions to this equation. But the only way you know that is by actually doing this. That's why I had to correct myself and change that plus right there. change it back to a plus, because had this been a minus, this actually would have worked. So it's subtle, but it's important. A lot of things matter here. The main idea is this, though. When we're looking at expressions, we either have linear factors just by themselves. We have repeated linear factors, which is a linear factor that's been either squared or cubed to the fourth power, or we have quadratic factors that are irreducible, which means we can't factor them. Those are like the three main categories of factors that we're going to look at in this class. All right. Okay. I'm done with the terminology. All right. We're ready to attack this problem now. All right. So I'm going to go back to this here. No, where was it? This one right here. This is the one we want to start with. Now, remember, at the end of whatever we're about to do here, at the end, our answer needs to be this, right? This is what we need as an answer. Now, you know, I told you that this is used in Cal 2, right? So in Cal 2, the reason this is used is because in Cal 2, we're trying to do something with this expression, and it's very difficult to work with this. It's actually really hard to work with this just the way it appears here. If we can get it to look like this instead, it becomes just a trivial problem. It becomes super easy to do the problem. So that's why the operation of going from here to here is so important. All right, so here we go. First thing we're going to do, first step, okay? So I'm going to put a list of steps here. Partial, fraction, decomposition, steps. First step, inspect degree of numerator and denominator. Okay, so we're going to do a quick inspection of the numerator and denominator's degrees. What is the degree of the numerator? Tyler? Tyler? 1. Degree of the numerator is 1. Good. Okay, what's the degree of the denominator? Is Tyler here? I'm looking for Tyler, I thought. No, no Tyler?
Squared.
I don't see Tyler here. Okay. Angelique?
I'm here.
Okay, so Angelique, what's the degree of the denominator?
2.
2. Okay, so we have degree of 1 on top and 2 on the bottom. Okay, so the first step is that we have to inspect those degrees. And now what we do is we make a comparison. All right, so A, if the degree of the numerator is smaller than the degree of the denominator, we move on to step 2, okay, which I haven't written down. Now, if, well, I'll just say otherwise, must do, you're going to love this, long division first. Now, if you did long division in college algebra, most students do not like long division, but it's here. Okay, we need it for this problem. We need it for these steps. Okay, so when we look at this, we inspect the degree of the numerator and denominator. Are we going to do A or B here?
A.
We'll do A first.
A, right? Because the degree of the numerator is 1 and the degree of denominator is 2. So we have that the case A, right? So we're going to move on to step 2. Thank goodness we don't have to do this step. Okay, so what is step 2? Step 2 is factor the denominator, just the denominator. Okay, so we're going to factor the denominator. And after we factor the denominator, identify the types of factors you have. So let's go ahead and just do that. On this problem here, I'm going to go ahead and move on. Step 1, check. We don't have to do anything. Step 2, I need to factor the denominator. Okay. Oops, I didn't factor it. So that step of factoring, if you're uncomfortable factoring, obviously you're already going to have trouble with this problem, right? If you can't factor that. Okay, now I factored it. Let's see, Allison, can you tell me what type of factors we have?
What type of factors?
Look at the denominator, look at those factors. What type of factors are those? So think about what we did just a moment ago, right? When we were looking at these factors.
Linear.
Yeah, they're both linear, right? Those are both just linear factors. This is linear. This one is linear. Okay. Now this is the best case, okay, that we can have. So now this is where the notes get really hard. When it comes to steps, it gets really hard for me to explain what to do next. Like in words. If I were to show it to you in words, here's what it looks like. So I don't want you to get too bogged down with this.
I had a quick question.
Yes.
If you had to do the long division, instead of polynomial division, could you use synthetic division?
Only if, remember, synthetic division can only be used when you're dividing by a linear, when your denominator is linear. Then you can use synthetic division. But if your denominator is not linear, you must use the long division. We're going to do an example. Yeah. Yeah. Unfortunately, you won't be able to avoid long division here. Like you're going to have to be able to do it. Synthetic is great, but it's less powerful than long division is. Okay. So yeah, no problem. So if what I was saying is, if I try and explain to you the next step in words, like write it down, this is what it looks like. And it's really hard to read and understand. It's confusing. So I think it's better for me to just show you what we're going to do. And then you'll kind of be like, oh, okay, that's not so bad. Because the way it's written mathematically is really kind of ugly. So here's what we're going to do. I'm going to write down. I'm just going to rewrite this to give myself some more space. Now remember, we had 2 linear factors, right? That's what we have. We have 2 linear factors down there. So what I'm going to do is I'm going to say that this must be equal to, and then what I'm going to do is I'm going to write 2 fractions. The reason I'm writing 2 fractions is because I had 2 linear factors. And now beneath each fraction, I'm going to put the 2 linear factors. The thing that I don't know is what numbers go up here, right? Do y'all agree? I don't know what numbers go up here. Now we do kind of know because we actually made up this problem, right? This is where it all came from. So we already know that those 2 numbers are 3 and 4, right? We know that, but we're acting like we don't. But this step is saying, hey, look, we need to now find, don't write this down. We need to figure out what that is and that is. Does that make sense? So instead of putting question marks there, what I'm going to do is I'm just going to put letters. I'm going to call this capital A and capital B. So do y'all agree now, if I write it that way, that if we can find capital A and capital B, we'll be done with the problem? Yes? Okay, so let's do it. So how do we do this? This is where things get interesting. What we're going to do is we're going to clear the fractions. Okay, so what we're going to do is multiply both sides of the equation by the LCD. LCD means least common denominator. The LCD of this problem is x minus 2 times x plus 1. We're going to multiply that here on the left. And we're going to multiply the entire right side by the same thing. And some really kind of cool stuff is about to happen. Ready? On the left, everything goes away except the numerator. Now on the right, for this example, I'm going to show this in detail, but in future problems, I won't show this much detail. We have to take these two factors and multiply it here and then here. So when we do the first one, we're going to have a over x minus 2, and it's going to get multiplied by x minus 2 times x plus 1. And then we have plus, then we have the b over x plus 1, and it's going to get hit with the x minus 2 times x plus 1. Is that clear?
Yes, sir.
Okay. So Lawrence, where's Lawrence? Lawrence here?
Yeah.
Okay, Lawrence, are you following okay?
Yes, sir.
Okay, so Lawrence, I'd like some help on this part in yellow. What is left here when I clean that up? What can I do there?
The denominator, right?
The what?
Factor out the denominator. Or
Did you
like-
say factor?
like yeah, or like get rid of it?
Yeah, you see this and this go away, right? Those two cancel out. And then on the other one, the x plus 1 cancels out. Right?
Yes.
So let's see what our next line looks like. 7x minus 2 equals, let's see, we still have the a here. So a, we still have the x plus 1 there. And then the other one, we have the b, and then we have the x minus 2. Okay, so we have cleared the fractions, right? So all of this together, what we just did was clear the fractions. Any questions? We're at the next step now. All right. So any questions at this point? We still don't know what A and B are. All right. So at this point, there are two different paths that we can go down. All right. There's two different paths. There's what I like to call the short way, and then there's the long way. Now the short way is nice because it's quick. The bad thing about the short way is it doesn't always work. The long way is, well, long, but it always works. So this problem, the short way is going to work. I'm going to show you both ways on this problem, just so you can see them side by side. And then when we get to problems later, when the short way fails, you'll know how to do the long way. All right, so here we go.
And then, excuse me, sir.
Yes.
I have a question. So like, since we're doing this class and next class, do you recommend us not to do the homework given to us until we cover both days, or?
Yeah, just, you would want to just look at the homework and see if you can handle any of it. And if you can't, don't worry about it.
And then just, if we have any questions, ask that next class.
That's right.
Alrighty.
Yeah, I actually might have to, oh no, because it's due, I believe it's due at the end of Tuesday. Yeah, so we'll have another class before. Yeah, so you would just attempt what you can.
Sir, I actually had a question about the homework now that
Yes.
we're talking about it. In my last class that I took at the college algebra, my professor, she actually wanted us to submit our work. Are you gonna do that? Like, do we need to submit our work to the problems through my math lab, or
No,
just?
no. So the idea here is this. Well, let me just say it this way. In my calculus classes, I don't even look at their homework. Like, it's not even part of their grade. Like, they don't get any credit for doing homework. The point being, at this point, right, pre-calculus, you should know as a math student that the only way you're going to get good at this and the only way you're going to do well in this class is by doing your homework. Right? That's the only way it's going to happen. So we're trying to get to that point. I'm trying to get you to that point where, look, I don't need to kind of babysit you all on the homework. I know you're going to try it. Now, if you want to submit your work to me and you want to like ask me for help, I'm happy to help. I'm going to provide you the solutions, but you don't need to submit it to me so I can check it off every day or anything like that. No,
Okay.
Just do the homework online and we're good.
Okay, thank you.
Don't just go to, because I know that there's a lot of websites out there you can just get answers. The last thing I want to see is that you got hundreds on all your homework assignments, perfect scores on everything. Then you come take the test and get a 15. Like, then I start wondering, how could you possibly have done that well? You know what I'm saying? So, okay, let's keep going. All right, so short method, here we go. So I've always liked this method because it requires a little bit of kind of creative thinking. We want to know what A and B are, right? We want to know what A and B are. So what I'm going to do is I'm going to look at this expression and I'm going to say, okay, I want to figure out what A is. So is there a way that I could actually kill B off and make B not appear here? And I can if I realize that if I replace X with 2, so imagine that that X was a 2, then wouldn't 2 minus 2 be 0? And wouldn't that kill this off? So I'm going to creatively say, let X be 2, okay? And now I want us to rewrite this entire thing with X being 2. Everything you see here, replace X with 2. So what would I get? 7 times 2, 14. I'll just write it down. 7 times 2 minus 2 equals A times 2 plus 1 plus B times 2 minus 2. But that 2 minus 2 gives me a 0. That's all gone now, right? And this is going to be what? 7 times 2, 14, take away 2, that's 12 equals, and then here 3 plus 2, that gives, I mean, sorry, 2 plus 1 is 3, and 3 times A is 3A. See that? And then solve for A, divide both sides by 3, you get A is 4. That was pretty nice. So now I know what A is.
And now you just sub that back in?
We could sub that back in, but actually we can do the same thing and get B. Okay,
Oh.
so let me see. I'm going to call on James. Is James here?
Yes.
Oh,
Yes.
James, you've already responded, but would you like to go for this one here?
Yes, sir.
Okay, so if James, if we wanted to figure out what B was, then we'd want to kill off A. So what could you replace X with to kill off A?
1.
Close. Not 1, because 1 plus 1 would give you 2.
It would be -1.
-1, good. So James is going to let X be -1 and then rewrite the whole equation again. All right. So 7 times -1 minus 2 equals A times -1 plus 1 plus B times -1 minus 2. That goes away. And be careful here, -7 take away 2, that's -9. And then over here, those two together give you -3, so we get -3b. And then dividing both sides by -3, you get 3. So b is 3. All right. So let me scroll back up. Remember, we said we started with this thing. We did step 1, we did step 2, we identified, and then we started doing this. And we've said, look, A over this plus B over this, and we know what A and B are now, right? A was 4 and B was 3. So that means if I take this and rewrite this, A was 4 over X minus 2 plus B was 3 over X plus 1, that should be the partial fraction decomposition of that rational expression. What do you think?
So
that's a little more work than the first problem I gave you where I said, hey, add these together, right? When we add them common denominator, we got the answer very quickly, right? We were probably done with that right there within 2 minutes. But going from this back to the original, partial fraction decomposition takes a little while, all right? Now, ready for the long way?
Sure.
Okay, so here's the long way. The long way is that we don't play this clever game where we try and can't kill off the B or kill off the A. Instead, what we do is this. We just distribute A through and distribute B through, and then rewrite everything. So let me go ahead and do that. So we'll have 7x minus 2 equals, let's see, a times x plus a times 1, which is a, plus b times x, minus 2 times b, which is just 2b. All right, any questions there on what I did? Just distributed that through? Okay with that? Okay, next thing I'm going to do is collect like terms. So I'm going to, those two have x's in them, right? So I'm going to put those next to one another. So I'm going to have 7x minus 2 equals ax plus bx plus a minus 2b. So that's just rearranging things, right? Just moving things around. And then the next thing I'm going to do, it's going to look weird, but just do this. What I did here is I looked at these two terms. They both had x, right? They both have an x in them. So I factored an x out. But instead of factoring it out to the front, I factored it out to the back, right? So normally you would take an x out, you pull it out and put it right here, but I put it in the back. And you'll see why in a moment. Algebraically, it's the same thing. So, it doesn't change problem. Okay, so here we are. We've collected like terms, we've factored out. So watch what I do here. What I know is that this is an equation, right? This is an equation. So the left and right-hand sides have to be equal to one another for this to be true, right? It must be balanced. So if I look at the number that's in front of x, that has to be 7, right? And notice that on the right-hand side of the equation, the thing that's in front of x is a plus b, right? So what that tells me is that whatever a plus b is, it has to be 7, right? You're basically setting those two equal to one another. And then the next thing I know is that the number here that's out here by itself, minus 2, must match up with everything over here that doesn't have an x on it. So that means these two have to match. So what I can write there is that a minus 2b must be -2. Do y'all see what I've done here? I matched the a plus b to the 7. I matched the a minus 2b to the -2. Questions? Does anybody recognize what we have here from college algebra? What we call this?
A system of equations.
It's a system of equations. And in college algebra, you should have learned how to solve a system of equations. You have two choices. You have substitution or you have elimination. Those are your two choices. Does anyone have a preference on how they'd want to do this?
Elimination.
Elimination, that's the way I would do it. So if you were going to do, who's saying elimination? Was that Anna Marie?
Yes, sir.
Okay, so if you were going to do elimination here, how would you do it?
I would subtract the two
Okay,
equations together.
so you would just subtract the two. So, okay, that's interesting. You wouldn't like multiply the top one by -1 and then add the 2. You would subtract instead.
If I were just like subtract the bottom equation, I would have to multiply the minus throughout, correct?
Subtract the bottom. Yeah, I guess when you're saying subtract the 2, I guess that's the part that's kind of, normally when you're taught elimination, you're taught to like figure out how you can get these two to cancel. Like if you add them together, how do they cancel? So you would multiply the top equation by
yes, sir.
-1, put a -1 through there.
Yes.
Okay, all right. That's when you said subtract, I was a little bit like, okay, I'm not sure I'm following that, but so we multiply everything by -1 on top. We'll leave the bottom one alone. And now that these two are opposites, we can add these two equations straight down. And if I add down, the a's go away. And if I add down here, I get -3b. And over here, if I add down, I get -9. And -3b equals -9 means b is 3 if we divide both sides.
Quick question, where did you get the -1?
Okay, so that was something I had to think of. When we were at this step right here in green, when we have all this, the whole idea of elimination is to try and figure out what you would have to multiply one of these equations by to make the a's be opposites. So -1 times a would give me -a, and that way when I add it to the other a, they go away.
And now that we have the 3, we don't have to do this again. We can just do the 7 minus 3 to find the missing, right?
Yes, yes. But Carolyn, are you clear with what I'm saying, Carolyn? You sure?
Yeah, you had to make them like opposites.
Make them opposites. Now, let me point something out. You have complete freedom here to do this however you want. So in other words, you could have decided to multiply the top by 2. And now watch what would have happened if I did 2. I'd have 2a plus 2b minus 14. And then the bottom equation is a minus 2b equals -2. And now do you see, Carolyn, that if I add these two straight down, do you see what goes away? The b's go away this time, and I'm left with 3a equals 12, and that would give me a is 4. So when it comes to elimination, if this is confusing you, like if you don't remember, just go back and review it, or that's where you go get some tutoring on elimination substitution. But there, you have a lot of freedom with elimination on how you attack it. But you just need to understand what tools you have to attack it.
Okay, yeah, I understand. Thank you for explaining.
Okay, no problem. All right, so now, where are we at? We were at b equals 3. And at this point, I think James said, I'm not sure who said it. We don't have to go through the same process again. What we can do is we can just grab one of these equations. A plus b is 7. And just replace the b with 3. So a plus 3 equals 7. Subtract 3 on both sides, you get a is 4. So we get the same 2 answers, don't we? Okay. Short way, very nice. Let's use it when we can. Long way, we will only use it when we have to. And I haven't given you an example of one where we have to yet. All right. Y'all hanging in there okay? Day one here. All right, I want you to go through the first steps here on your own. So the first 2 steps, I'll write them, or I'll copy them over here for you. Whoa. All right, so for this problem, I'd like for you to at least get through the first 2 steps. I'm going to give you a minute or 2, and then I will call on some people. I'm just going to stop my video real quick, but y'all go ahead and see what you can do with that. I think that's probably sufficient time to at least get through the first two parts. Let me see. Is it so young?
Yes.
Okay, so did I say that right? So young, both together?
I'm sorry?
Did I say your name properly? So
Yes,
young?
yes, they are
Okay,
together.
all right. Okay,
Yeah.
very good. Okay. All right. So how'd you do on this? First step?
Yeah, first step, I just passed it because it was okay.
Yep.
So I went down to step 2, which I got x over x minus 6 times x plus 1.
Does anybody disagree?
I
Yes.
got x minus 3 and then x minus 2.
Yeah, I got the same thing.
Let me see. This is a tricky one. This is a classic example. So young. This is a problem I like giving my college algebra students because it's so easy to get tripped up on this one because your instinct wants to do this minus 6 plus 1, right? To get the minus 5 to work, you do the minus 6 right here. But the problem is on the last multiplication on the FOIL, you get negative 6, not positive. So you got to mess around with the 3 and the 2, right? Okay, no big deal. We got it. It's going to be the second one, right? Everyone okay with that? Okay, so now that we have this, what we're going to do is we're going to say, all right, well, let me write it this way. Because I have two linear factors, right? These are two linear factors. I know that it's going to be two fractions added together. And let's see, is it Michael Clark?
Yeah.
So Michael, can you tell me what I should write here for these two fractions? What should be in the denominators?
X minus 3 and x minus 2.
Okay, x minus 3 and x minus 2. All right, and what should I put on top of those?
A and B.
A and B, all right. And so again, we've got to do basically the same thing we did in the last problem. We got to go after A and B, right?
Yeah.
Go figure out what they are. So Carolyn, do you remember the next step, Carolyn, that I did?
Yes, after this, you multiply both a over x minus 3 and b over x minus 2 by the denominators.
By the denominator. So that we're going to do the LCD on both sides. And look, everyone, the LCD will always be this. Every time we do partial fraction decomposition, that's your LCD right there. So we're going to do that on the left and the right.
So it will always cancel out?
That's right. And that's why we do it, because this will always go away. And then you have just x over here. Don't forget that you will still have the numerator. The numerator will be over here. And then here, when we distribute this here and here, I'm not going to show the work as much on this one. So maybe Lauren can help us. So Lauren, is Lauren here?
I'm here.
Okay, hey Lauren. Are you following okay, Lauren?
Yes.
Okay, good. So Lauren, when I take this right here and I distribute it through to this one, what cancels?
The x minus 3.
Okay, so that would mean you're left with what still?
8, or it'd be a times x minus 2.
There you go. Okay. And then you did good with that. So what would the next one be?
It would be the b times x minus 3.
Very good. Okay, good. So that's what you get. And let's see, Genesis. Is Genesis here?
Yes.
Okay, I see your name there. Genesis, are you following?
Yes.
Okay. Do you know what the next thing we should do is?
Find A and B.
Yes. So we have two paths we can go down now, right? The short way or the long way? You want to try the short way first? See if it works?
Yes.
Okay. So did you understand the short way that we did? We were trying to kill off one of the letters.
Mm-hmm.
So Genesis, if I want to kill off the B here, what if I want to kill this off? What would X have to be to kill off that whole expression right there? So what X would I have to plug in right here to make this thing become a 0?
3.
3, right? So that by letting X be 3, that'll make that 0 to kill off all the B stuff here. So now what we do is we rewrite the whole problem, the whole expression, replacing all X's with 3's. So the left side is 3 equals A, and then 3 minus 2, and then plus here, I'm just going to put plus 0 because we already know that that's all going to go away. 3 minus 2 is 1, and 1 times A is A. So this is just A is 3. Okay, is it Yamna? Did I say that right? Yamna?
Yes, sir.
Okay. Are you following okay, Yamna?
Yes.
Okay, so we figured out what A is. How can we figure out what B is? What will we need to do?
We can put like x equal to plus 2.
Yep, let's let X equal positive 2, and that will kill off this one over here. Right, okay, so we'll do that. We'll write 2 equals, let's see, we know that that's all going to be a 0 plus B, and then we have 2 minus 3 there. So rewriting X is 2 here and here and here, and that's what we got. And this gives us 2 equals B times negative 1, right? Because 2 minus 3 is negative 1, so that's negative B. And then divide both sides by negative 1, right? Negative 2 is B. Okay, so Yamna, since you're still on here, can you tell me what our final answer will be then?
We can put 3 over x minus 3.
Yep.
Plus negative 2 over x minus 2.
Yep. That's it. So just everyone, what's happening here, all we're doing is we're going back up to this one right here. We're replacing the A with A. Don't get these mixed up. Okay, you can't swap them on accident. The A is getting replaced with 3, and the B is getting replaced with negative 2. And we box that up, and that is our answer. So if we were to add those two together and get a common denominator, if we were to do that, we would get back to this. This is what it would turn out to be. All right. Good. So now here's the next one. Let's go through this together. We're getting close on time here. So let's see how far we can get with this. The first step on this one is to look at the degree of the top and bottom. The degree of the top is 1, degree of the bottom is 3. So we're going to skip right on to step 2, which is to factor. So let's take a look at the factoring of this. All right, so if I were to factor that, can somebody tell me the first step of factoring anything? Like no matter what, if you're asked to factor, what's the first step always?
To take out a common term.
Common factor. Greatest common factor is always your first factoring technique. So all of these have an X. So I'm going to pull an X out. And then what's in the parentheses is a trinomial. So basically we're going to do what we were doing before, try and factor that. And does anyone know what that turns out to be? It's a little tricky, this one, but it does factor.
It's x minus 1 and x minus 1.
X minus 1, x minus 1. Good. Good, good. So, this is the first time this has happened. We actually have a linear factor here, and we have the same linear factor here, right? Those are the same thing. They're not different. So what we are getting here is that repeated linear factor. Remember when I talked about repeated factors? This is a repeated one. In fact, we could look at it this way. You could rewrite this like this, right? X minus 1 times x minus 1 is, I'm sorry, x minus 1 times x minus 1 is really x minus 1 squared. So this is what we have in the denominator. So let me rewrite it. I'm going to write it down here. It was x plus 2 over, we have x, then x minus 1 squared. Okay. This is different, okay? Things are about to change. What we've done so far has been pretty straightforward because, like on the previous problem, when we did the whole factoring, we had two factors that were different, right? So what we did on the next step is we put two fractions and we just put a and b on top of them, right? No big deal. Now, when we have something like this, things are going to change. And here's what we're going to do. And this is going to seem strange, but like I said, it's best if I show you rather than, again, trying to show you the steps, because here's the steps. Where is it? Yeah, it's this one right here if we have repeated factors. So it's just, again, hard to read. So let's do it this way. Okay, first thing I'm going to do is put an x down here. And that's because I have that linear factor right there. X by itself is a linear factor. So I'm going to put x there, I'm going to put an a here. Okay. The next thing I'm going to do is I'm going to write x minus 1 and put a b on top of that. And then I'm going to do another fraction and I'm going to do x minus 1 squared and put a c on top of that. Now, I know that's strange, but just do it and then we'll talk about why. And I think it's best if below this, I show you a different example, and that way you can, it really will kind of illustrate what I'm doing. Okay, so on this problem, I had an x here, I just did a over x. Then what I did is I said, look, I've got this linear factor that's being repeated twice. So I just write the linear factor down, I put a b on top of it. And then I write the repeated linear factor with a c on top. If I were to follow that same method on the bottom, or with this different example, it would be x here in a, then watch, x minus 1 with a b, then x minus 1 squared with a c, plus x minus 1 cubed with a d, and then x minus 1 to the 4th with an e. Do y'all see what I'm doing here? It's like, I count how many I have, right? I have 4 of these, and what I'm going to do is I'm going to put the linear factor, and then I'm going to keep on just raising the power. It's going to be this linear factor just by itself, then that linear factor squared, then cubed, then to the 4th. And I was kind of building it up. Do you see that? Any questions?
So you keep going until you get to the power that you had in the
Keep
original
going,
problem.
exactly, until you get to the power that you have here. Now in this problem, because we only went to 2, I only had to do it twice. Is that clear to everyone? Now, again,
Yes.
this is the way that it's written in mathematical language. If you have some linear factor to the kth power, you're going to put that linear factor with some number on top of it, that linear factor squared with some number on top of it, plus dot, 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 means you keep on repeating that pattern until you get to that linear factor to the kth power, where k was the power here. See, so it's really hard to read this sort of like math language. So hopefully this makes more sense just written out. All right, we are going to continue this. What would be the next step? Clear them fractions.
Solve for
right?
A, B, and C.
Clear them out. left side, right side. Okay, on the left, they go away. You get x minus or x plus 2. On the right side, we have to distribute. So here to here. And let me ask someone here. Let's see, Jackson, you've already answered, but I'm going to call on you again. Jackson Kinder. When I do that first multiplication through here, what cancels? What goes away?
The x.
X. So you'll still have a, right? And you'll still have x minus 1 squared. Let's keep going, Jackson. What would happen on the second multiplication? What cancels?
X minus 1.
Just one of them though, right? Just one of them. So we still have the b. Do we still have the x, Jackson?
Yeah,
Okay, and do we still have an x minus 1?
I believe so.
Just one though, right? Because this really means we have two of them and one of them cancels, so we still have an x minus 1 there. All right, you're doing good, Jackson. Let's keep going. C, what would go away on the last one there?
X minus 1 squared. So you just
Exactly. So you'll still have cx. Good.
Yeah.
Perfect. Thank you. All right, everyone. We only have like 3 or 4 minutes. Let's see if we can get this or not. Any questions on that step? We're going to hope that we can get this with the short method. Let's go for short. All right, so if we go short method, let's see, Jordan Leal. Is Jordan here?
I'm here.
Okay, Jordan. Jordan, I'll kind of help you out on this. What would you have to let x be to kill off c? If I want to kill this c off, what would you have to let x be?
I'm not sure.
Okay. Let me put it this way to the whole class. Let's focus on this a different way.
0.
Okay, yes. If I'm trying to get a, I'm not sure who said 0. So let's say I'm trying to figure out what a is. Okay, let's look at it this way. If I'm trying to figure out what a is there a number that we can pick for x that would kill off this one and this one at the same time? Now, who said 0? Okay, Maddie, good. So notice that if we let x be 0 here, this will become a 0 and it'll kill everything here, and then 0 will kill everything here, won't it? Do y'all agree with that? So let's try that. Let's let x be 0. If we let x be 0 and we rewrite everything, we get 0 plus 2 equals a times 0 minus 1 squared, and then plus everything else is gone. I'm not going to be able to finish this problem, but I want to at least figure out what a is. So let's just finish this part up. This is 2 equals, now be real careful here. 0 take away 1 is -1, but then -1 squared is +1. So this is just a. So we know what a is, don't we? Okay. We're about to finish, but I want to present you now with I think maybe it'll become apparent why this may not be able to be done with the short method. Let's see. Let's try and figure out what b is. So this is a question to the whole class. Can I let x be a number that's going to kill off this and this at the same time?
No.
No.
No, right? In order to kill this off, I have to let x be 0, right? But if I do that, it's going to kill this off. So I can't let x be 0. To kill this off, I have to let x be 1, right? But if I let x be 1, it's going to kill off this also. So do y'all see there's like no easy way to get b? And that sucks, right? Now, could we get c? Let's see if we could get c. Maybe we can get c. Is it possible to figure out what this is? So can we kill off both of these at the same time? By letting x be what?
1.
1. If x is 1, it'll kill these off, but it won't kill this off. So I'm going to leave this to you. This is the end of class. We're going to come back and finish this up. We still have 1, 2, 3. We have 3 more examples to work through next class, and they get a little more complicated because we start having irreducible quadratic factors and things like that. This is the basic start for us. So for tonight, your homework is really just to make sure that you can get into the Pearson website and that you can get to these problems. And then let me just look at the questions real quick. So I'm going to tell you which problems that I want you to do. So skip all the way and do, which problem is this? I can't tell which problem this is. Oh, do number 6 for the homework. Do number 6. No, we're not even ready for that one. Yeah, just do number 6. These other ones, yeah, just make sure you can do at least 6. These other ones, we just haven't done examples yet. That's at least one problem for you to do. So get enrolled in WebAssign, and we'll come back. Have a great weekend, and we'll come back next week and hit it hard and get it done, okay?
I have one question. So if we like do the homework and like we just do 6, will it save our progress through this website?
Yep.
Okay.
Yeah, you can always leave and come back. Anything else? You're free to go, but I'll hang out if you have any questions.
Thank you.
And
Bye. Thank you.
Thank you.
I have one other question. I saw where we'll have like some like reference sheets for like equations and stuff on the test or exams. Can we use those?
Yeah, I just put those on our website this morning.
Yeah.
Yeah, these formula sheets, you'll be allowed to use these.
And just show you them on the camera.
Yeah, you'll have to hold them up and show me. But that means you're going to have to print those out well before the exam.
Okay.
If you don't have a printer, you're going to have to figure out a way to get that done.
Oh, yes, sir.
Yeah.
All right. Thank you.
Anyone else?
Hi, sir.
I have a question. Do you post the notes?
Oh, yeah. Everything I write here, I'll save this as a PDF, and then I will, I'll send it out to everyone.
Okay, thank you.
Yeah, I'll probably just email it to you, just to the whole class. Thank you for reminding me about that.
All righty. Thank you.
Bye. Thank you.
All right. Thank you.
And just to clarify, you said that the only homework problem would be 6 for right now?
Yeah, just do that one problem because we still have a lot to do before you can handle the whole assignment.
Okay.
Yeah.
Thank you.
Okay. No problem. Have a great day.
You too. Bye.
Bye-bye.